Welcome back, everyone, to Computer Science 150. Uh, Today, we're actually going to jump ahead a little bit in the textbook. Uh, you may have noticed from the lecture notes that I posted last time that I have given you some assigned reading from chapters 1 and 2. That's the bulk of what we're going to be doing this week, is focusing on those two chapters. However, since next week, especially in the lab assignment next week, we're going to be working on some material that comes from chapter 3. I actually want to do a little bit of that material out of sequence. So what I'm going to be doing today is I'm going to be talking about some material that actually comes from chapter 3. I'm also going to be assigning some reading from chapter 3. But again, my purpose in doing this is to introduce you to these topics well in advance of the lab coming next week. So in particular, for those of you who have lab on Tuesday, you'll have an opportunity to have seen this material already this week, and you'll also have an opportunity to do the background reading to understand this material a little bit better by the lab time on Tuesday. All right, so let's begin with a quick review of some of the things that we discussed last time. All right, so last time I showed you this first basic example of a Java program, which does all of the most common things that Java programs do. The first thing that the program does is it's set up to receive input that the user types. And to do that, we make use of a mechanism called a scanner. And then to get the actual input that the user has provided, we do a couple of things. First of all, we have a print command that prints a prompt that tells the user what they're expected to enter. And then by using a command that makes use of the scanner, we actually tell the scanner to wait for the user to type a number, and then whatever number they type, that's going to get stored into a variable. So that's one aspect of what a program needs to do. It needs to be able to get some input from a user. Then at the other end of the process, of course, the other thing that a program needs to be able to do is it needs to be able to present output to a user. And it's going to be doing that by the use of a print command. Typically, when a program does a calculation, it'll have some result at the end. And at the end, you'll see some sort of a print command that's designed to output that result and show it to whoever is using the program. All right, and of course, the main action here is once you've received the input, you'll want to do some sort of a calculation with it.
Not as soon as
And even
possible.
in this very first, very basic example, you see a simple example of a calculation taking place. We're going to do some simple arithmetic calculations involving the value that the user entered. In the process, we're going to convert a Fahrenheit temperature to a Celsius temperature and then eventually print that output. All right, so even this most basic example that I showed you on Monday has three of the key elements that you're going to need in a Java program. It has some way to get input from the user. It has some way to do a calculation by doing some simple arithmetic, and then it has some way to produce output. All right, now when we operate in this mode, the program that we write is really nothing more than a glorified calculator. And of course, what this program is capable of doing is essentially the same that you would be able to do yourself if you had access to a calculator to do the arithmetic for you, and you could just use that as a mechanism for doing the arithmetic. All right, now, the topic that I'm going to introduce today is essentially the first true programming topic that we're going to encounter. And the topic we're going to talk about today is a facility in the Java language that allows you to make decisions. All right, so I've brought along another very simple example that illustrates how this decision procedure is going to work. And then in the lecture today, we're going to focus in great detail on how this particular language element actually works. All right, so here's a second example program. In this example program, we're dealing with a concept from mathematics. You may remember from algebra class when you're dealing with polynomials, in particular second-degree polynomials, one of the common tasks of working with polynomials is finding roots. And you may remember the infamous quadratic equation that you use to find roots of a second-degree polynomial. And one aspect of that is determining what kind of roots a polynomial has, because there are three cases. A second-degree polynomial can have two real roots. It can have a single real root, or it can have no real roots. Now, because there are three possible outcomes here, that means we have to engage in a little bit of a decision process. We have to gather some information, and based on that information, we have to make some sort of a decision about what's going to happen in a particular scenario. All right, so here's an example program that illustrates that kind of behavior. So first of all, again, we're setting up to receive input from the user. We're going to prompt them to enter some information. In this case, what they're being asked to enter is the coefficients of the polynomial. The polynomial that we're talking about is a times x squared plus b times x plus c. And a key piece of information we need here is what the coefficients a, b, and c are. So we use the input mechanism to get those coefficients. And then when we start dealing with the quadratic equation, there's a key element of the quadratic equation. It's a part of the equation called the discriminant. And that's computed from the coefficients by basically computing b squared minus 4ac. You may remember that from your algebra class. Right now, one of the things that discriminant factor tells you is it tells you what kind of roots the polynomial has. And there are three cases. One is if the discriminant is negative. That means the polynomial has no real roots. The second case is if the discriminant is 0, it means the polynomial has one real root. And the third case, if the discriminant is positive, it means you have two real roots. Right, so because we have three cases here, what we need next is a language mechanism in Java that allows us to tell which of these three cases we're in, and then to do something appropriate in response to each of those three cases. All right, so this is the new aspect of Java that we're going to be talking about today. In today's lecture, we're going to be studying a very important construct in Java, a thing known as the if-else construct. And the basic purpose of the if-else construct is it gives you the opportunity to ask questions about what's going on in a program and then make decisions based on the outcomes of those questions. Right, so here's how the if-else statement works in the case of trying to determine which of these three cases we're in. The first thing that happens in an if statement is we have the keyword if, and then inside parentheses, we have what is essentially a test. Right now, test is effectively a question that is phrased in such a way so that it has either a true or false answer. In this case, the question we're going to ask first is the discriminant less than 0? In other words, is the discriminant negative, right? Because that's one of the three possible outcomes. And if that's true, we're going to do something in response to that. And if it's false, we're going to do something else instead. Right now, the basic structure of an if-else statement is we first do the test. The test has two possible outcomes, either true or false. And depending on which of those two outcomes we get, we're going to go one of two places next. All right, so the first possibility is if the test evaluates to true, then the next thing that we have following the test is there's a pair of curly braces, and inside the curly braces we have what's called the if case. This is this set of things that we're going to do if the test evaluates to true. Right, so in this case, the test was simply to ask, is the discriminant negative? And if the answer to that question is true, the appropriate outcome is to print a message simply saying that the polynomial has no real roots. That's the so-called if outcome. Now, the second possibility is that the test could evaluate to false. And if the test evaluates to false, we have a second portion of the statement. This is what's called the else branch. And in the else branch, we do what we're going to do if the answer to the question is false. Right now, in this case, if we learn that the discriminant is not negative, we have to follow that up by asking a second question. And the second question, well, if it's not negative, there's still two possibilities left. One is that the discriminant could be 0, and the other is that the discriminant could be some positive number. So to resolve those last two cases, we also ask a second question involving another if statement. In the second if statement, the question is simply, is the discriminant 0? And if the answer to that comes out true, we have the if case, which basically prints a message saying, oh, in that case, the polynomial has just one real root. And if the answer to this question is false, then we have an else case that says, well, in that case, we we're basically in the case now where the discriminant must be positive, and if the discriminant is positive, in that outcome, we have two real roots. Okay, so this is what we're going to be talking about today. In the course of today's lecture, I'm going to introduce you in much greater detail to the if-else statement. But what this simple example here demonstrates is that the if-else statement is basically a mechanism in Java for asking questions and then responding based on the outcome of those questions. You can ask a question that has either a true outcome or a false outcome, and then you can provide two cases for what to do if the answer is true and what to do if the answer is false. Okay, so now let me switch over to a set of lecture notes, and let's go a little bit more detail and talk in a little bit more detail about how the if-else statement works, and look at some of the more basic mechanics of the if-else statement. All right, so here's another example. Again, in this example, we are getting some input from the user. We're going to need to ask a question. To ask that question, we'll be using an if statement, and the question will have two possible outcomes. All right, now this example is a little bit simpler. In this example, we're asking the user to enter an integer. And because there are two possibilities for integers, integers can be negative or they can be positive. Immediately after we ask the user to enter their integer, we're going to ask a question. And for that, once again, we'll use an if statement. Right, so in the if statement, we're going to simply ask a question about the value that the user just entered. If the value they entered is negative, then we have one outcome that goes in the if branch. And if the value they entered is not negative, there's a second outcome that goes into the else branch. Right, now, what we're trying to do in this example is we're actually trying to compute the absolute value of the number that the user entered. So if they entered a negative number, the absolute value is going to be the negative of whatever value they entered. On the other hand, if they entered either 0 or a positive number, then the absolute value of the thing they entered is simply the number itself. Right, so once again, here's a basic example of using an if statement to distinguish between two cases. The cases are determined by whether or not x is negative. If it's negative, we have one outcome, and if it's not negative, we have another outcome. This is a basic construct that allows us to make a decision about what's going on and to respond appropriately. All right, so then finally, after we've computed the absolute value of the input, we then can go ahead and print a message saying, okay, the absolute value of the number you entered is this. All right, very basic example of using an if statement to make a decision and then respond appropriately based on what's going on with a particular value in the program. All right, now, here's the next thing to talk about is, again, let's focus more specifically on the if statement itself, and let's remove the distraction of all the other parts of the program here. Again, let's look more closely at how an if statement is structured, and again, point out the key parts of an if statement. All right, so the first key part of an if statement is the test. The test always has to be enclosed inside parentheses. And in a few minutes, we'll talk about a variety of ways that you can make tests, but here's a very basic example. We're asking a question about the value of a variable x. We're simply asking the question, is x less than 0? Or in other words, is it negative? Right? And whatever question we ask has to be phrased in such a way that it has a strict true-false answer. It has only two possible outcomes, and those outcomes are either true or false. Right, then we have the two cases. We have the if case and we have the else case. And the way that we separate those cases from each other is that each separate case is enclosed in a set of parentheses, in a set of curly braces. As we saw on Monday, Java uses curly braces pretty extensively to mark out different sections of things. And here we're using curly braces to mark out both the if part and the else part. Right, so this is the basic structure of an if-else statement. It's the main requirements are that it has to have a test, and it has to have two possible outcomes and two possible areas that show what you want to do in each of those two cases. If the test is true, we have some code that will run in that case. And if the test is false, we have alternative code that runs in that case. Okay, so that's the basic structure of the if-else statement. Next, let's talk about some variations you can make on the if-else statement. The first variation is that you have some flexibility in how things are formatted. The first form that I showed you is probably the most highly structured. And one aspect that you might not like about this is that this tends to take up a lot of space. If you structure things in this way, you'll notice that it takes, looks like a total of 6 lines of code to make this one construct. Right now, eventually, when you start writing programs, an issue that you're going to run into is that you're going to be concerned with getting as much useful stuff to appear on the screen as possible. And in that scenario, you might want to make things shorter. Right? So here's an example where a structure takes up a total of 6 different lines of text. But one of the nice things about Java is Java gives you lots of flexibility in how you format things. All right, so here's an alternative way that we could format this. This is still perfectly legal. This is still a perfectly legitimate if-else statement. The only difference here is I have changed the way that the various parts have been structured and formatted so that the thing simply takes up less space on the screen. Right? And Java gives you lots of flexibility in terms of how things are formatted. You can rearrange the components of something like an if-else statement. The only requirement is that the various parts have to be there in the right order when read from left to right and top to bottom. But as long as all the key parts are there, you have a lot of freedom and flexibility in how you format these things and how you organize these into statements. Another even extreme version of this is we could in fact put this entire thing on a single line of code. You could take the second part, the else part, and the branch that comes after it. You could stick that at the end of the if part, and you could manage to wedge this entire statement onto a single line of code. Right? So if you're interested in getting things to appear very compactly, Java will even allow you to do that. Right? Now, here's another variant that you can use. Another rule that's associated with the if-else statement says that if one or the other of the two branches consist of just a single statement, in that scenario, the curly braces that you would normally see there are actually optional. And again, the rule says you can only use this option if each of these branches consists of exactly one statement. If there's more than one statement in a particular branch, you have no choice but to go back to the original version that has the curly braces in it. For more than one statement, you absolutely do need curly braces. Right now, my advice for all of you as beginning programmers is that when you're beginning to learn how to program, I would suggest that whenever possible, you go ahead and put the curly braces in. Because even though they take up a little space, it's a good practice to always put the curly braces in around both the if part and the else part, because that way you'll always be guaranteed to have exactly the right structure. Now, as you get a little bit more comfortable with writing if-else statements, if you remember this rule that says in the case of a single statement, you can drop the curly braces, eventually you can feel free to drop them. But again, my advice at this point is to always keep those curly braces in to show the full structure of the if-else statement. Right now, here's one other variant that we can pursue. Something that you might notice in this example is that in the example that we're talking about, there are two cases. In one case, if x is negative, the absolute value of x would be essentially the negation of that. And in the other case, if x is not negative, the absolute value is basically what you would get if you just left that number alone. Right now, this is another sort of special case. This is a situation where you have an if statement with two branches, yet one of the two branches isn't doing much of anything useful. In particular, the else branch here, about all it's doing is it's copying a value from one variable to another. And this is almost a not terribly interesting statement. All right, so let me show you another way you can structure this. Here's another option you can pursue when you're working with an if-else statement, and that is sometimes in an if-else statement, you can drop one part of the statement. In particular, the part that's optional is the else part. Because in some scenarios, you may ask a question, and you'll discover in that scenario something interesting is going to happen if the answer is true, but if the answer is false, nothing in particular interesting happens. So in that case, the else part is optional. You can actually write an if statement that has an if part and not an else part, and do something only if the answer to the question is true. All right, so here's another way to structure this whole thing. Again, we start by asking the user to enter a number, which could either be positive or negative. The first thing we do is we copy that number into the second variable, the absolute value variable. But then we say, hey, wait, there's the possibility that that number was negative. If it's negative, I need to do something different. So for that, we'll use an if statement. We'll say, hey, if the number they just entered is negative, what I need to do instead is I need to put the negative of x into the absolute value. And in this case, if it turns out that the number is not negative, there's nothing new I need to do. In that case, the absolute value variable already has the right value in it. There's nothing special I need to do in that case, so I can leave off the else part in situations where there's nothing to do if the answer to the question turns out to be false. All right, so that's another variant you can pursue. In some cases, the else part is optional and you can leave it off. All right, so let me pause here and ask if anybody has any questions about anything that we've said up to this point about if statements and how they work. Okay, if not, let's go on and talk in a little bit more detail about one very important part of the if statement, and that is the test. As we've seen, every if statement has to have a test, which is basically a question you ask. And the main mechanism that we have for asking questions involves what are called comparison operators. And here's a list of 6 different comparison operators that are available in Java. And as the name suggests, these are all things that are used to compare two things to each other. All right, so here are 6 different ways that you can compare two values to each other and turn that into a true-false question. The first of these that you write by typing a pair of equal signs is the question that basically asks, are these two values the same? And that's used to basically compare the values of two variables and simply ask, do these two variables have exactly the same value? A variant on that is the not equal operation. For that, we use a combination of an exclamation point and an equal sign. Here, the question we're asking is the value of the thing on the left not equal to the thing on the right? All right, and then finally, we have various comparisons involving inequalities. You have strict inequality, you have less than or equal to, you have greater than, and you have greater than or equal to. And with these 6 different ways of comparing values, that covers a lot of ground in terms of being able to compare the values of variables and ask basic questions about how variables compare to each other. All right, so these are the 6 key comparison operators, and this is by far the most popular way to make a test that asks about variables. We make a test by comparing things to each other. Right now, one thing that I want to comment on explicitly, and this is one of the most common simple programming mistakes that people can make, and that involves the use of this first comparison operator. This is the comparison operator that asks the question, are two things equal to each other? And a very common mistake that beginning programmers will make is they will forget that for that type of comparison, you have to use 2 equal signs and not 1. And that leads to this mistake. This is probably one of the most common programming mistakes that you can make, and that is forgetting that in the case of checking whether or not two things are equal, you have to use 2 equal signs, and you accidentally use just 1. Right now, I want to comment about this specifically because this is especially dangerous, because this is one of the cases in Java where you can make a mistake and accidentally type the wrong thing. And even though it's a mistake, Java will let you go ahead and do this anyway. Right? Here's what happens in this case. If you forget that the comparison operator where you're checking whether or not two things are the same involves 2 equal signs, and you accidentally write 1 equal sign, you get something like this. Now, what this will actually do, this isn't a comparison, this is actually a command. This basically says, go ahead and set n equal to 10. Right, so what this statement actually does is, instead of asking, is n equal to 10, it actually goes ahead and sets n equal to 10. And then it asks, what's going on here? Now, there's another obscure thing going on here, is that if you do this this command, which basically says set n equal to 10, as a side effect of doing that, that part of the statement evaluates to the value that you just set. This basically evaluates to 10. Right now, an obscure fact about Java is that in Java, you can actually put a number as a test. And the way that Java interprets numbers as tests is that if the number is 0, it considers that to be false. And if the number is anything but 0, it considers that to be true. All right, so what's going to happen in this case? First of all, instead of asking, is n equal to 10, this is actually going to go ahead and set n equal to 10. Then as a side effect, it's going to produce the value 10. And the if statement, when it sees that number 10, it will automatically interpret that as true, which means it's next going to go ahead and do this branch here. It's going to go ahead and set n equal to 0. Right now, what ends up happening here is that momentarily the n gets set equal to 10, but then right away it gets set equal to 0. And that's going to happen regardless of what was going on with n in the first place. All right, now that's probably not what you meant in the first place. What you really meant was you wanted to ask, is n equal to 10? If so, I'm going to set it equal to 0. What we ended up with instead is a situation that sets n equal to 0 no matter what's happening with n. N will always get set equal to 0 in this case, which is an error. Okay, so to make a long story short, when you are comparing values with each other, make sure to use the double equal when you're checking to ask whether two values are the same. Okay, now back to the example that I showed a few minutes ago. Here's another thing that can happen with if-else statements. This shows an example of what's called a nested if-else statement. And in a nested if-else statement, what you can actually do is you can actually put one if-else statement inside another one. Right now, there's a very common scenario in which this takes place. The most common scenario in which this happens is a scenario in which you start out by asking a question. So in this case, the first question we ask is the discriminant negative? Right now, if the answer to that question is true, we know immediately what we need to do. In that case, we can just immediately print a message saying, hey, in that case, I know that the polynomial has no real roots. End of story. I'm just going to print that, and that the situation is fully determined. Now, in the case where the answer to the question is false, we then find ourselves in a situation where you then have to ask a follow-up question. Right? Because what's going on here is the first question we asked is the discriminant negative? Now, if the answer to that question is false, it means that there's still two possible cases left. The two remaining cases are that the discriminant could be 0 or it could be positive. And since there are still two cases left, to resolve that situation, what we have to do is we basically have to ask a follow-up question. All right, so after the first question, which is the discriminant negative? If the answer to that question is false, we have to ask a follow-up question. And the follow-up question is the discriminant equal to 0? All right, and it's only after we get a chance to ask that follow-up question can we resolve the situation completely. So if after the second question we learn the discriminant is actually 0, then we can say, aha, we know what's happening now. The polynomial has one real root. And if the answer to the second question is false, we can then also say, aha, I know what's happening in that case. I basically have figured out that the discriminant is positive, and in that case, we just have to print a message saying that the thing has two real roots. Right, so this is a case where you have to ask not only a first question, but a second question, and the way you do that is by basically embedding one if statement inside another one. Right, so what happened here is that we have the else branch of the first question, and embedded inside that is a second question, which we use a second if-else statement to set that up. Okay, now as you can see, this all starts to get a little bit more complicated and potentially more confusing. And again, this is a case in which having the curly braces is very helpful. Excuse me. Because again, the curly braces go a long way towards showing you the actual structure of what's going on here. The first set of curly braces show you very clearly that this first bit of material here, that is the if part of the first if statement. Then the second set of curly braces, which run from here all the way down to here, that basically shows you that all of this stuff here makes up the else part of the first if-else statement. All right, and then inside the set of curly braces in the second else, we then have space to put in the other statement that we want to put in, and that can sit inside the structure made by the curly braces. All right, so again, this is a situation where having the curly braces goes a long way towards showing you the actual structure of what's going on, and especially when the structure starts to get more complex, having all those curly braces is very helpful for getting the structure exactly right. All right, so again, let me pause here and ask if anybody has any questions about this example or what's going on here. Okay, now next, let's talk again about variance. So again, we have this somewhat complicated if-else structure here. Let me now show you some variants to this that you can create. Here's one variant that you can create. You might remember a few minutes ago I said that in some cases the curly braces are optional. Again, the rule that applies for that is that if one part of an if-else statement consists of just a single statement, in that case, the curly braces that would normally go around it are completely optional, right? So here's a case in which that rule applies. In the first if statement, the if part, if the answer to the question is true, what we're going to do in response to that is just a single statement. And since this whole thing basically counts as a single statement, this rule comes into play. So in that case, the curly braces are optional and we can dispose of them and they're not needed for this part. Now, in this case, there's other places where you can get rid of the curly braces. In this case, in the else part consists of an if-else statement. And a rule in Java is that even though this looks like a very big, complicated thing, technically an if-else statement is a single statement. And since this entire thing, even though it spans several lines of code, is technically a single statement, this is another scenario in which the optional curly brace rule would kick in. In that case, since this entire thing, the entire else part of the statement, technically counts as a single gigantic statement, again, the optional curly brace rule kicks in and you can leave out the curly braces. All right, and likewise in the if-else statement, in the second if-else statement, since each of the two branches of that one consist of single statements, again, the curly braces are optional and you can dispose of them in that case. Right, now, once again, having shown you that in some cases the curly braces are optional, my actual recommendation is, at least until you get a lot more comfortable working with if-else statements, I would not use this rule. Instead, for the time being, I would go back to being much more careful and always putting the curly braces in, because at least until you get much more comfortable working with these constructs, it's always a good idea to put the curly braces in and be very explicit about what you're doing. This is much less likely to lead to errors and to unexpected results. Right? So for the time being, even though the curly braces may be optional in many cases, I would still recommend using them in most cases unless you have a reason not to. Right, now, while we're on the subject of optional curly braces, the optional curly braces allow us to do another trick here. All right, and this is a little bit subtle. If you look at the difference between these two slides, in the first slide, I set up the structure in such a way so that I made it very obvious that this stuff from here down to here is essentially the else part of the first if-else statement. All right, now, because this is a situation where we're putting one if-else inside another, this leads to a scenario that shows up pretty commonly in programming. And because this scenario shows up pretty commonly, what programmers will sometimes do is they're going to change the formatting of this in a very slight way and write it this way instead. Okay, so there's just a very subtle difference in the formatting between these two, but even though the formatting looks a little bit different, both of these forms mean exactly the same thing. In both cases, there is an outer if statement that involves a first question. That first if statement has an else part, and then that else part has a second if else as part of its content. Okay, now, the reason that I show you this structure here is that this structure goes with a scenario that shows up very commonly in programming. This is a scenario where we're doing what amounts to a classification. What's going on here is we have a variable. We have this discriminant value, and that discriminant is something that can be classified into one of three cases. The three cases are negative, 0, and positive. And the way that we distinguish between those three cases is through some if-else statements, right? So the first if-else statement basically looks for the first case. Is the discriminant negative? Then the second if-else statement looks for the second case. Is the discriminant 0? And the third case is basically what we call the default case. This is the case you fall into if neither of these two questions has an answer of yes. If the answer to neither of these two questions is yes, that means we're on the default case. In this case, the default case says that the discriminant is positive, and for that, we don't need to ask a third question. We can just have the default case sitting at the end. Right, so this ends up being a very commonly used variant of if-else statements. This is used in scenarios where there are multiple cases, and there are questions that you can ask that drop you into each of these cases. And if so, you can set up a series of if-elses that test for the different cases and allow you to categorize things into different categories. Right, so this construct is a thing called a chained if-else statement, and it shows up pretty frequently in practice. Right, so let's look at another example here. Here's a more complicated example. This is an example that involves classifying something into 4 possible categories. What's going on in this program is that this is a program that does a calculation called a BMI calculation. A BMI is what's called a body mass index. This is a okay, I think somebody accidentally hit record on their thing. Okay, sounds like that stopped. All right. Okay, so in this calculation, this is what's called a BMI calculation. This is a calculation where you take information about a person's height and weight, and you use that to compute what's called a BMI index. Right now, the BMI index is subcategorized into several different categories. So in this calculation here, we basically take some input from the user. We then compute a BMI value, which is stored in this BMI variable here. And then we categorize that BMI value into one of 4 possible categories. Right? And these categories are determined by a set of 4 questions we can ask. The first question is the BMI value very low? The way this scale works is that if you have a BMI value of less than 18.5, you're considered underweight. So the first question we ask is this an underweight BMI? The next question to ask is this BMI value less than 25? If it is, you fall into the normal category. The next question after that is the BMI less than 30? With a BMI less than 30, you're considered overweight. And the final default category, which is basically the category where your BMI value is 30 or greater, that's considered obese. Right? So that's an example where we have a single value that can be categorized into one of 4 possible categories. And the way we set this up is by asking a series of questions that drop you into one of these categories. And then by asking enough questions, we can eventually determine which of the 4 categories you actually fall into. Right, so that's a somewhat more sophisticated example of a chained if-else that allows you to ask a whole series of questions, and by so doing, takes a single value and drops it into one of 4 possible categories. All right, that's something fairly sophisticated you can do with if-else statements. Okay, now here's the next thing I'm going to talk about in the relation to if-else statements. This involves what's called a compound test. Because sometimes when you ask a question, the question may be sufficiently complex that it requires you to ask what is effectively more than one question at the same time. And so what you need to be able to do that is you need a mechanism that allows you to ask more than one question. And the main mechanism in Java that allows you to ask more than one question at the same time are these operators that allow you to form what are called compound tests. right? And there are three operators that you need to know about. The first of these that you get by typing a pair of ampersands, this is what's called the logical AND combination. The second one that you get by typing a pair of vertical bars is the logical OR combination. And the third operator that involves an exclamation point, this is what's called a logical negation. Now, to show you how this works, let me show you some examples of how these operators are used in practice. Here's a first example. Sometimes in mathematics, you're concerned about whether or not a particular variable falls into a range. So here's an example of a situation where we have a number that's stored in a variable x, and what we're trying to determine is whether or not that number falls in some range that I'm interested in. And the range that I'm looking for here is the range that starts at 5 and ends at 10. Okay, now, the problem with this is that to determine whether or not you're in this range, you actually have to ask two questions. The first question is x greater than 5? And the second question is x less than 10? Right? And it's only if the answers to both of those questions are true that you know for certain that x is in that range. Right? So to resolve this and determine whether or not x is actually in this range, we need to ask a pair of questions. And the way we do that is by asking two separate questions. The first one is x greater than or equal to 5? And the second one is x less than or equal to 10? And then we combine those two questions by using what's called a logical operator. In this case, the logical operator that we're using to combine these two is the AND operator. Right? So the question that we're actually asking in this if statement is it true that x is greater than or equal to 5? And is it also true that x is less than or equal to 10? Right, so that's how we would determine whether or not a number falls into a range. To do that, we have to ask two questions, and the way that we ask two questions at once is we form the two separate questions, and then we combine them by this AND operator. Right, now, when you're reading this, these pair of ampersands, these are read as simply as AND. So the question here reads, if x is greater than or equal to 5 and x is less than or equal to 10, then you know that x is in the range and you can go ahead and print a confirmation message. Right? So that's an example of a compound test that's formed by taking two separate questions and then combining them with an AND. Right, now, here's another example. In this example, we're basically going to write a short, simple program where somebody's going to enter a number for a month. So they're going to enter a number from 1 to 12 from January through December. And we're going to set up an if statement that prints a message telling them how many days are in that particular month. Okay, so here's the basic setup. So first of all, the first basic question to ask is we check for a special case. February is a special case. So the first question we ask is the month equal to 2? If the month is 2, we know it's February, and as long as we can assume that it's not a leap year that we're talking about, the number of days in that month would be 28, and that's that one special case. Right, now, after that special case, there are two broad possibilities. Either the month has 31 days or it has 30 days. And the way that we distinguish those is there's a whole series of months that have 31 days, and there's a whole series of months that have 30 days instead. Right, now, the only way to determine if a month has 31 days is to simply write out all the possibilities. All the months that have 31 days are January, March, May, July, August, September, and December. All right, so those are all the months that have 31 days in them. And the way that we catch all of these cases is we write a separate test for each one of those months. And then we combine all of those separate tests by using what's called an OR combination. All right, so this is basically read if the month is 1, or if the month is 3, or if the month is 5, and so on and so forth. If any of those cases turn out to be true, then we're in this case, and we know that the number of days is 31. All right, and finally, the last case, the so-called default case, is if none of these other cases apply, we know that the month has 30 days, and we go ahead and handle that case at the end. right? So there's an example of how you can use the OR combination to combine a bunch of different cases and basically say, if any one of those cases is true, we know that we've got 31 days in the month. Okay, so again, a short pause here and ask for questions about any of these last few examples here. Okay, now that we've seen some basic examples of if-else statements, the last thing I want to talk about today is the fact that in some circumstances, it may actually be quite challenging to come up with the right test for the situation that you're looking for, right? So let me pull up a separate document here and show you the situation we're talking about. This is a somewhat complex situation involving intervals on a number line. What's going on here is we're going to have 4 values, and these 4 values represent the endpoints of a couple of intervals, right? So let's imagine that we're writing a program, and in this program we have 4 variables, A, B, C, and D. Each one of these variables is a real number, and these variables basically represent a couple of intervals that are on the real number line, right? So the first interval runs from A to B, and the second interval runs from C to D. Right, now let's suppose we're writing a program, and at some point in the program we have to answer the following question, and the question is, do these intervals overlap in some way or do they not? Right, so in the picture here, here's an illustration of a situation where the intervals would not overlap. The intervals are set up in such a way so that the first interval from A to B sits to the left of the second interval, and these things are now completely separate from each other and they don't overlap. Okay, now here's a somewhat challenging question we want to figure out the answer to. Can we write an if statement that can look at these 4 variables and answer the question, do these intervals overlap or do they not? Okay, now if we're going to write an if statement that can answer this question, maybe the first thing we want to start thinking about is, what are all the ways that these intervals could possibly overlap with each other? Right, now this gets pretty complicated. Let's shove these things around and show you that there's a lot of different cases to worry about. Right, here's one case. In this first case, what's going on is that the CD interval does actually overlap with the AB interval, and it does it looking something like that. Right, now you could tell that you're in this case because in this case you have this kind of overlap basically because C is less than A, and at the same time D is greater than A, and also D is less than or equal to B. So if you wanted to, you could write an if statement that checks for this scenario. Right, now here's another scenario that you could look for. In this scenario, they overlap, and they overlap because the second interval fits completely inside the first one. And if you had to, you could write out some tests that checks for this situation. In this situation, what's going on is that C is greater than A, and at the same time, D is less than B. That's how you would check for that situation. Right, now, here's another scenario. Oops, and I may have just messed myself up here because I've just made it impossible to create this. But another scenario would be the one in which we have the green interval overlapping. In fact, let me see, I might be able to manufacture this. Okay, yeah, let me do this and get back to here. Now I can get, sorry. Let me get back to the case where I can, there we go. All right, so here's this scenario. So here's another scenario. In this scenario, the things overlap in this way. And if you want to, you could write if statements. Okay, so what we're starting to see here is that this is a situation where what we're talking about is very complex. There's actually several different ways that the intervals could either overlap with each other or not overlap with each other. And if you think through all the different scenarios, there's a bunch of different cases that you have to test for. Now, in principle, what you could do here is you could write, as we saw in the last example, you could write a whole series of if statements that check for each of the different scenarios. And for each of the different scenarios, you write a test that asks, is that scenario happening or is it not happening? And then you categorize this into various different ways that these things can either overlap with each other or not overlap with each other. Okay, now, needless to say, that gets to be a real mess. And let's, in fact, here also written out in words is all the different scenarios that can take place. It turns out there's 6 different scenarios here. And because there's 6 different scenarios for what can happen, you have to write essentially a set of 6 separate if-else statements to categorize these scenarios. Yuck. And this turns out to be a huge mess when you try writing this out in code. Right now, let's look at a much better and easier way to do this. Sometimes when you start trying to write if statements to answer a particular question, you may discover that the question is really hard to get a handle on. Right? So in this scenario, what's going on is that the question was, is this a case where the 2 things overlap with each other? Right now, in cases where they overlap with each other, that's very complicated. There's different scenarios and different tests you have to write. Now, sometimes if you're trying to capture something and you discover that it's too hard to write a test for the thing going on, sometimes a better approach is to instead ask the opposite question. Can we figure out the scenarios in which these things don't overlap? All right, now, this is actually quite a bit simpler because in the case of these intervals, there's only 2 ways that they do not overlap. Here's one scenario. In this scenario, they don't overlap, and they don't overlap precisely because C is greater than B. Here's the other way that they can't overlap. In this scenario, they don't overlap precisely because D is less than A. All right, so what's going on in this case, it's actually much easier to say when the thing is not going to happen, and that in turn makes it radically easier to write an if statement that resolves this situation. All right, so here, by using just a very simple test, we can have 2 scenarios in which they don't overlap. If B is less than C, or if D is less than A, the intervals don't overlap, and that resolves the situation fully, and that allows us to write it finally as a fairly simple, straightforward if-else statement. Okay, so I see at this point that unfortunately, this is getting to be a habit of mine. As I've run over time a little bit, we're out of time for today's lecture. The last thing I want to leave you with is in the lecture notes for today's lecture, I also have some suggested reading. These are the sections in chapter 3 that cover the basics of the if-else statement. And my main request to you is that you try to get this reading done by lab time next week. All right, so those of you who are in the Tuesday lab, you'll need to make sure that you read these sections before Tuesday. And those of you who are in the Thursday lab will need to make sure that you read these sections before class on Thursday. Okay, now for the next lecture on Friday, what I'm actually going to do is I'm going to go back to some of the sections that we covered in the lecture on Monday, and we're going to go back and talk about some of these things in greater detail. So in the lecture on Friday, we're going to go back and talk more specifically about a bunch of topics that come from chapter 2. And again, I've assigned reading associated with that. What you're going to want to make sure you do is finish that reading by the end of this week. Okay, so you've got quite a bit of stuff to do for the time being. You've got some reading to do in chapters 1 and 2, and then in preparation for next week, you've got some reading to do in chapter 3. This is the main stuff you're going to be doing for the next few days, is getting caught up on the reading so that you'll be ready for the lab exercise that comes up on next week. Okay, so once again, sorry for running a little bit late today. That's all that I have for you today. We'll see everybody back either in lab on Thursday or back for lecture on Friday. So have a good day until then.